All right, today we're going to pull back the curtain on something that's absolutely essential but totally invisible inside every single gadget you own. We're talking about the unsung hero that makes everything feel fast, cache memory.
So let's really get into this. You know that feeling, right, when you get a new computer or a new phone and everything just feels, well, snappy? What is that? It's not just one thing, of course, but a huge piece of that puzzle, a huge part of that feeling of speed, comes down to this secret ingredient we're going to unpack.
Okay, so to really get what the secret ingredient does, we first have to talk about a huge, fundamental problem that's happening inside every computer all the time. Think of it like this. It's a constant, high-stakes waiting game between two really important players.
All right, first up, let's meet the star of the show, the CPU, the Central Processing Unit. This thing is the brain of the whole operation. It does all the actual thinking, crunching billions, literally billions of calculations every single second. It is just unbelievably fast.
And then you've got its partner, the main memory, what most of us just call RAM. Now, you can think of RAM as this enormous library. It holds all the data, all the instructions, everything the CPU could ever need to do its job. It stores a ton of stuff, but, and this is a big but, compared to our super fast CPU, it's kind of slow. It takes a while to go find a book in that library and bring it back.
And this right here is the heart of the problem. It's what we call the speed gap. You've got the thinker, the CPU, revved up and ready to go, just burning through tasks. But it's constantly hitting the brakes, just waiting. Waiting for the library, the RAM, to slowly deliver the next piece of information. This gap, this waiting game, creates a massive, massive bottleneck. The most powerful part of your computer is just sitting around twiddling its thumbs.
So what do you do about that? How did engineers solve this massive waiting problem? Well, they could have just tried to make RAM faster, but they came up with something much, much smarter, a really clever fix. And that's where the hero of our story comes in, cache memory.
So what exactly is it? Well, here's the key idea. Cache is a small, but, and this is the important part, an extremely fast little pocket of memory. It acts like a buffer, or maybe a better way to think of it is like a super fast personal assistant that sits right beside the CPU.
Okay, to really make this click, let's use an analogy that I think makes it super clear. Imagine you are the CPU. Your job is to get some work done. Let's say write a report. You're at your desk, ready to go, and all the information you could ever need is in a big library just down the hall. So here's how you'd work. You need a piece of information for your report. What's the first thing you do? You don't just jump up and run to the library, right? No, you first check the little stack of books you already have right there on your desk. That's your cache. If the info you need is in one of those books, boom, that's a cache hit. You grab it instantly and keep working, no delay. But what if it's not there? That's a cache miss. Now you have to stop everything you're doing, get up, take that long walk down to the library, our slow RAM, find the book, and bring it all the way back. And here's the really clever part. When you get back, you put that book on your desk, because you're making a bet you'll probably need it again pretty soon.
And this really gets to the core philosophy behind the whole thing. It's all about smart prediction. The goal is to anticipate what the CPU is going to need next and have it ready and waiting. The entire system is designed to get as many of those super fast cache hits as possible and to avoid those slow, painful trips to the library. It's all about keeping the CPU busy doing actual work, not just waiting around.
Okay, so that's the techie explanation. But so what? Why should you care about any of this? Well, the answer is pretty simple, actually. You feel the payoff from a good cache every single day, every time you pick up your phone or sit down at your computer.
Think about it. When an app on your phone pops open the second you tap it, that's cache. When you're browsing the web and a page just snaps into view, cache. When you're playing a game and it's perfectly smooth with no stuttering, yep, that's cache too. That quick access to a file you just worked on, that snappy feeling of the whole user interface, it's all the magic of cache working perfectly behind the scenes.
And really, that's what it all boils down to. It's the difference between being in the flow and just feeling pure frustration. Cache is that invisible piece of engineering that makes our technology feel seamless instead of clunky and slow. It's what saves us from staring at loading bars and spinning wheels all day long.
So, to wrap things up, I want to leave you with this one last thought. We've talked about how cache is basically a really fast, predictive short-term memory for the computer. But its entire success, everything it does, depends on guessing correctly what the CPU is going to ask for next. And that leads to a really interesting question, doesn't it?
What happens when it gets the prediction wrong?